Hello and welcome to Technical Utkranti, and today we are going to see the first question in our recursion series, which is sum of all subsets. But before that, let's look at the thought for the day. All right. So this is a second video in this series, and this is the question. So question basically states that you have an array, and you need to return the sum of these subsets, and so this is the array, and you need to find all the subsets, and then of all the subsets, you need to find the sum and return the sorted such a sorted array. So, in order to further understand it, let's look at the whiteboard. What we want is that we need to find the sum of all its subsets. Okay, so one will be the empty or the null subset, another would be subsets of length 1, then subsets of length 2, and then the entire set is also one of its subset. What would be the sum? It was 0, 1, 2, 3, 3, 5, 4, and 6. And if you sort them, it would be 0, 1, 2, 3, 3, 4, 5, 6. So this is what the answer is expected. All right. Now let's have a look. How can we do it with the help of recursion? So what we need to do is to decide at each element whether or not we will include it. Okay. So when the pointer is at the first element, we include the first element or we do not include the first element. Then we shift the pointer one ahead. All right. So earlier the input was the array and the pointer pointing to the zeroth location. At the second recursive call, the input is the array and the pointer pointing to the first location or n equal to 1. All right. So what is recursion? Recursion is calling the same function for different inputs. All right. So here the input was this, and now here the input is this. Or the change is the shift in the value of the pointer. Okay, fine. Now we take the same call for this element. All right. So include it, do not include it. Sorry, do not include it, do not include it. Then again, the pointer shifts one position ahead, and then it becomes the same include it, do not include it, include it, do not include it, include it, do not include it. Sorry, include it and do not include it. So in this way, we get all the subsets, and instead of like creating the subsets, we can just have the sums. So it will be 1, 0, then 3, 1, 2, 0, then 6, 2, sorry, 3, 4, 1, 5, 2, 3, and 0. Right? So let's look at the code, how we have implemented it. So this is the recursive call. Index is starting with 0, sum is starting with 0, num is the array, right? And then subset will hold the all the sums of the subset, and this n, the length of the array, would be useful in writing the base condition. But first let's have a look at the recursive condition. What we are doing is, at each index we are either including it in the sum, or just remaining letting the sum remain as it is, which means we are not including the index in the sum. All right. And then we hop on to the next index. So this first call represents the left leg of the tree that we were seeing, where we were including, right? And the right one represents the the down one represents the right leg where we do not include, right? So this is executed for left, and then this is executed for right. And in this way, at the end of the at the end of the base condition, we include the sum in the subset, and at the end we return, and subset is then sorted finally. Okay. uh, what is the time and space complexity of this operation? For n equal to 3, we have 2 to the power of n subsets. So this many sum needs to be stored in a separate array. So 2 to the power of n is the space complexity of this operation. Then what is the time complexity of the recursive operation? So we need to find 2 to the power of n subsets or sums, plus we need to further sort it. So sorting would further take this much. So n log n is the time complexity of sorting, but there are 2 to the power of n sums for n input. So this is further required for sorting. So this is the time complexity, and this is the space complexity. So I hope you understood the problem and how we have implemented recursion in it. So please give it a like and subscribe to my channel. Thank you. Bye bye.